What is up, Math Scholars? Today we're doing the 10.3, 10.4 study guide video. It's a beautiful sunny day, so are you thinking bike ride trampoline after school?
No.
Yes, you are. Who's excited to do a study guide?
No.
Woo! Woo!
Don't watch the video.
Okay, everyone. Did everybody find their 10.3 trigonometric identity paper? You have to have two best friends, your identity paper and your unit circle. And if you can't locate those things, maybe I'll print some extra ones for tomorrow to give you those things. So let's peek at our trig identity paper. I would leave my cosine exactly as is right here. So let's leave it negative cosine x. But that negative with the tangent, we can use a specific property I'm thinking of. It's at the bottom. Negative angle identity. Yep. And what that allows us to do is pop this negative out front. So that was called the negative angle identity. Now I would really focus on that tangent. What can we replace tangent with from your sheet? I would do the sine over cosine, not 1 over cotan or anything weird like that. So tangent can be replaced with sine over cosine. That's called the tangent identity. I'm actually out of trig papers. I gave away my last copy yesterday. We do have double negatives, so they can turn to positives, and we do have these cosines that can cancel. So our final answer is just a regular old sine x. Okay. Okay, everyone. This one's a bit harder in the standpoint that you do have to rearrange your very famous Pythagorean identity. So the very famous Pythagorean identity is sine squared x plus cosine squared x equals 1. I'm trying my hardest writing with a stylus. So to make what I've got here look like what I have over there, I would need to subtract the cosine to the other side. So I'd have sine squared x equals 1 minus cosine squared x. It's called rearranging. So this here, this stuff on top, actually can be replaced with sine squared x. Everybody agree so far? Now do you have ideas? Looking for scholar ideas. Yes, now we have some stuff we can cancel. Let me catch up with my bad handwriting. The sines can cancel. I would have 1 over cosine squared x. But if you did your delta maths, you can remember we don't want to leave an answer like with the denominator. I don't want to leave my answer 1 over cosine squared x. So how can I write my answer? Secant squared x. That is your answer. Secant squared x. Let's go. Okay, number 3. This is going to be actually pretty easy. Do you have any ideas what we could do first? We actually did this yesterday. Ella? Common monomial factoring. Yeah, in yesterday's lesson we did common monomial factoring. That would leave me with sine squared x plus, because it's a negative 10 I'm removing, cosine squared x. And you should recognize this as the Pythagorean identity. Sine squared x plus cosine squared x is 1. And did you get negative 10 as your final answer? Yay! Okay, we're here on number 4. You do need the third Pythagorean identity on the paper, the one on the right side of the Pythagorean identity paper. So let me write down what you're going to want here. It is 1 plus cotangent squared theta. Let's make it an x. Equals cosecant squared x. Everybody found that identity? That's the one I think would help us the most because we could rearrange that one to look like that denominator. So if I leave this one where it's at and I subtract over the cotangent, then you're going to see what I'm seeing on that bottom. So the bottom can be replaced with what? 1, yeah. So my final answer is just cotangent squared theta. So these aren't that bad if you understand the concept of you are allowed to rearrange these identities to fit your needs. All right, number 5. I'm thinking we're going to have to rearrange that Pythagorean identity again, that really famous one. So sine squared x plus cosine. This doesn't write that good, and I'm pushing hard on the screen. equals 1. That's a plus sign right here. If I want it to look like my numerator, I'm going to need to subtract the 1 over to the left, but subtract the cosine part of it over to the right. Can you visualize that? So we'll have sine squared x minus 1 equals negative cosine squared x. Now, just a reminder, when we're verifying, we're not simplifying anymore, we're verifying. We're going to do all our work on the left, and we're never going to work on the right. We want the left to look like the right. So this numerator is now going to be instead a negative cosine squared x. On the bottom, I've got that cotangent. Why don't I go ahead and replace the cotangent now just to save some room with my work? Cotangent is going to be cosine over sine, but there's two of them, so it's squared. So cosine squared x over sine squared x. And then what do we remember about dividing by fractions? Multiply by the reciprocal. So I'll have this first fraction, or the numerator of my fraction, negative cosine squared x, and I'll be multiplying by the reciprocal of the bottom fraction. And hopefully you can see where I'm headed with this. It's going to cancel. The cosines are going to cancel. So I'm left with negative sine squared x equaling negative sine squared x. So I did verify that. Okay, the first thing that caught my eye on number 6 is this right here. That's straight off your sheet. It's called a co-function identity. What does it equal? Cosine. That's what I see. The next thing I can do is look up tangent on my sheet and replace tangent. So it's called a tangent identity at the top, second row. What does tangent equal? Sine over cosine. This one ends up being so easy. I can cancel out these cosines and I'm done. Sine x equals sine x. So no need to panic on number 6. Easy. Okay, there is a lot of stuff going on in this problem, so I kind of had to think about it a little bit. First, let's start with the secant on the upper left. What can we replace secant with? 1 over cosine. We're back to thetas instead of x's. I think this denominator here, this cosine, I'm just going to leave it there. Then we have a minus sign. Tangent, I'm going to leave that a tangent for now. But then cotangent, I'm going to turn into 1 over cotangent. So do you agree with all my replacements so far? That's okay. 1 over cosine. I've only done 2 replacements.
We like it.
Oh, 1 over tangent. Oh, thank you, thank you. Emergency, emergency. 1 over tangent. Got it. Okay. Now, when you divide by something, you multiply by the reciprocal. So what actually happens with this cosine is I have 1 over cosine that I multiply by the reciprocal of the denominator. So I multiply by 1 over cosine. So it becomes 1 over cosine squared. Everybody agree so far? I'm not messing up? Yeah, gotta watch me make sure I'm not messing up. The second one, it becomes tangent times the reciprocal of the denominator. So tangent times tangent. And that becomes tangent squared. I'm going to scroll to get a little more workspace. We're getting really, really close. 1 over cosine squared theta is secant squared theta. Then I have minus tangent squared theta equals 1. And I keep looking at Lewis's paper here because I don't have my own. Secant squared theta minus tangent squared theta would equal 1. It's the second trig identity rearranged. So at that point, you got it. I'll go view full screen so you can see the whole entire problem. And all right, number 8. This one, I'm getting an easy drift from this one. I'm getting an easy drift. First replacement, I think, should be this guy. Another co-function identity. So what does it equal? Cotangent. I agree. Now, I never replace signs, so I'm going to leave that sign, and I'm not allowed to work on the right, so I'm going to leave that cosine. Next replacement. Who do you think we should replace? The cotangent, correct. The cotangent I can replace with cosine over sine. And then the signs will cancel, I hear them saying in the back. And then we are done with our little baby proof. That was an easy one. Hey guys, in the video, it's time for a new best friend. Who should your best friend be now? Your unit circle. All right, I did find my unit circle. Notice we're solving these equations in the interval 0 to 2 pi. So you do not need that plus 2 pi r trick that we've been doing in class. You don't need that on the quiz at all. What should I do as my first step? Add the 1 to the other side. So I'm just going to put it on the other side as a positive 1. What should I do as my second step? Divide by 4, so it'll be a 1/4 over there. What should I do as my third step? Square root both sides. Now square rooting introduces something very important. Plus or minus sign. That's an equal sign. That's a plus or minus sign. The square root of 1 is 1. The square root of 4 is 2. So I'm going to be heading to my unit circle, looking for all the places where sine, or the y value, is positive or negative 1/2. There should be 4 places. We have enough space right off for the answer. Where's the first place? I agree. Where's the second place? I think 5 pi over 6. Hey, this is a good trick. If your denominator is going to be a 6, your denominator is always going to be a 6 the whole way. So now 7 pi over 6. And this is a 6, by the way, just not writing. My handwriting is not up to snuff with this. 11 pi over 6. So yeah, you don't want like 2 of your answers to have a 6 in the denominator and then 2 of your answers to have a 4 in the denominator. It means you messed up. So 6 is for all. There's your 4 answers. Number 10. This is like yesterday's lesson, 10.4, day 2, meaning we're going to be using factoring in the zero product property. So what do you think I could factor out front? What's the common monomial? I agree. So factor out a common sign out front, leaving 2 sine x minus 1. Because if you remove sine from itself, you're still left with a 1. That's a 0 there. And you do have to be set equal to 0. So maybe it would be required that you subtract stuff over to get it equal to 0. Okay. Now it's the zero product property. If this times this equals 0, either sine x equals 0 or 2 sine x minus 1 equals 0. Equal sign. Okay. So to solve this first one, there's an or in here. It's all the places where sine could be 0 between 0 and 2 pi. So 0 and pi, right? And I'm not gonna do 2 pi. Look at your interval at the top. And then to solve this, I would add the 1 to the other side. And then I would divide the 2 to the other side. And I need all the places where sine is positive 1/2. Positive 1/2 this time, so there's less answers. Pi over 6 and 5 pi over 6. And I think that's it. I think there's only 4. Okay, here's where we're at. What should I do first? No! Subtract over your 2. This kid's getting kicked out of the scholar group. Yeah, but not yet. Oh. So now I'm going to divide everybody by negative radical 3. Those 2 negatives will turn to positive. And so what I have to do at this point is called flip it, flip it. It's highly scientific. So if you flip cosecant upside down, you have what? Sine. And if you flip 2 over radical 3 upside down, you have radical 3 over 2. So I'm now headed to my unit circle, looking for all places. My computer like kind of froze. Oh no, I can't have my computer freezing in the middle of the video. All right, good news. My computer did not freeze. I bumped my stylus off. So I'm looking for all the places where sine is radical 3 over 2. A unit circle. Positive 5 pi over, no, pi over 3. And then over there at 2 pi over 3? Does that look about right? Okay. You were saying 5 pi over 3. Sine's negative down there. Okay, wow, this is really similar to what I was talking about a few minutes ago. When you have signs on both sides of the equal sign, they want to be together. So how can I get my sign on the right to join my sign on the left? Add it over there. And when I add it over there, it's very important you don't mess this up. Sine x plus sine x is 2 sine x. I was having board buddies the other day making that sine squared, but that's what blobfish would do. What should I do next? Subtract that radical 2 over. What should I do next? Divide both sides by 2, and then it's unit circle time. Where is sine x negative radical 2 over 2? 7 pi over 4 is one place. 5 pi over 4 is the other place. Number 13, what should I do first? Add the 1 over there. What should I do second? I feel like we saw one like this earlier. The very first problem, was it the same as this? Oh, okay, so it's similar but different. So since we're doing square root again, I still need that plus or minus. The square root of 1 is 1. The square root of 4 is 2. So this time, there will also be 4 answers, but we're looking for cosine values instead of sine values. Cosine values of 1/2 are x values of 1/2. Pi over 3. 2 pi over 3. Yeah, 4 pi over 3. I had a brain freeze for a second. And, yep, 5 pi over 3. Okay, last one. This is another flip it, flip it. Who's excited? What should I do first? Add the 2. You're not ready to flip it until secant or cosecant are alone. I guess I should have said that on the last one. You're not ready to flip it until your secant or cosecant are alone. So at this point, we are ready to flip. If I flip secant upside down, what do I get?
1 over cosine.
So if I flip secant upside down, I get cosine. If I flip 2 upside down, I get a half.
1/2.
So there's going to be 2 answers. Where is cosine positive 1/2?
Pi over 3.
And?
5 pi over 3.
No. Oh, yeah, you're right. You're right. You're right. Brain freeze.
Yeah.
I was thinking of sine. Never mind. I was thinking we were headed to quadrant 2. All right. Well, thanks for watching the video with us, fun little audience at home. And we're going on a field trip, I guess. So see you guys later. Bye.